Hey everyone, and welcome. So glad you're here. Today we are diving headfirst into the absolute bedrock of DevOps, and that is Linux and shell scripting. Seriously, this is where it all begins. We're going to go on a journey from, just clicking around manually to being able to command thousands of servers with just a few lines of code. Sound good? Let's jump right in.
Okay, so here's what we've got on deck. First, we're going to cover the foundation, like why do servers even run Linux in the first place? Then we'll talk about a crucial mindset shift, thinking in commands. After that, we'll get our hands dirty with our first essential commands and then move from doing things by hand to automating them. And we'll wrap up with the key to making it all work, permissions. It's going to be a packed one.
All right, let's kick things off with Section 1, the foundation. We're talking about why servers run Linux. Look, before you can command a system, you've got to understand its most basic parts, right? How they talk to each other. So let's lay that groundwork.
So let's get super basic for a second. Think about any computer. It's really just two things, right? You've got the hardware, that's the physical stuff, the guts of the machine, the CPU, the RAM, all that. Then you have the software. These are the programs and apps you're actually using. Simple enough.
But here's the million-dollar question. How do they actually work together? Well, here's the thing. Your software, say your application, it can't just talk directly to the hardware. It's like they speak different languages. It needs a translator, an interpreter, and that's the whole job of the operating system, the OS. The OS is that essential middleman. It takes your command, translates it, and tells the hardware exactly what to do. It literally manages everything.
Okay, so why Linux? I mean, you're probably using Windows or a Mac on your laptop right now, right? But in the professional world, on the servers that run everything, Linux is mandatory. There's no debate. Why? Well, for one, it's super lightweight and fast. It doesn't have a big, clunky graphical interface eating up all your resources. It's also built to be incredibly secure right from its core. And honestly, it's just the industry standard. It's what everyone uses. And yeah, you'll hear about different flavors like Ubuntu or CentOS. Those are just distributions. Think of them as different brands, but underneath it all, they're all running the same powerful Linux kernel.
Okay, our foundation is set. Now for the next part, which is honestly a huge mental shift. This is where we change how we talk to computers. We have to ditch the mouse, stop thinking in clicks, and start speaking the server's native language. And that language is commands.
So get this picture out of your head right now. On a real live production server, this just isn't a thing. There's no pointing, no clicking, no dragging and dropping. That entire graphical world you're used to, it's gone. It doesn't exist there.
What you get instead is this, a simple blinking cursor. This is the command line interface, or CLI. And believe me, it might look like something from the 80s, but this is where the real power lives. This is your direct line to the heart of the operating system. It's faster, way more efficient, and trust me, it's infinitely more powerful than clicking a mouse could ever be.
All right, we know our environment. Now we need to fill up our toolkit. Let's go over the absolute essential commands, the ones you're going to be using literally every single day. And we're going to approach this by asking, what do I want to do first? And then I'll give you the command.
Okay, this is always the first question, right? You've just logged into a server, you're sitting in some folder, and you're thinking, now what? What's even in here? The command for that is lsltr. Let's break that down. ls just means list. Easy. Now, those letters after the dash, we call those flags. They just change how the command works. L gives you the long format, so you see all the juicy details. T sorts everything by time. And R reverses that order, so the newest stuff is always at the bottom, which is super useful. In just one little command, you get a ton of information. That's the power we're talking about.
All right, next up, what happens when your brain just blanks? And trust me, it happens to everyone, from a total beginner to someone who's been doing this for 20 years. You know there's a command for what you want to do, but you just can't remember it. Well, don't sweat it. Linux has your back.
The command is man, and it's short for manual. This is your secret weapon. Seriously, anytime you're stuck, just type man and then the name of the command you're curious about, like man ls. Bam! The entire official manual for that command pops up right there in your terminal. Learning to use man is the key to teaching yourself anything you need to know.
Okay, you need to edit a file. But guess what? There's no notepad or text edit on a server. The one editor that's always there is VI. Now I'm going to be honest, it feels a little weird at first, but you'll get the hang of it. Here's all you need to know to get started. First, you open the file with VI and the file name.
To actually type something, you hit the I key for insert mode. Type your stuff. When you're done, hit the escape key to get out of insert mode. Then to save and quit, you type :WQ for write and quit. If you messed up and just want to bail without saving, it's :Q with an exclamation point. That's it. That's the basic dance for editing files on literally any Linux system on the planet.
But what if you don't need to edit a file? You just want to peek inside real quick. Well, opening VI just for that is kind of slow. That's where the cat command comes in. You just type cat and the file name, and it spits the entire contents of that file right onto your screen. It's perfect for a quick look at a log file or a config file.
Okay, so we've got our basic tools, we can move around, we can look at files, we can even edit them. Now it's time to level up. Let's talk about how we take these individual tools and use them to build automation. This, my friends, is where we stop being just an operator and start thinking like an engineer.
And this right here, this is the whole game. A manual operator? Sure, you can manage one server by hand. Maybe 5. But what happens when your company has 10,000 servers? There's no way you can do that by hand. It's physically impossible. An automation engineer, on the other hand, writes one script that does the exact same job on all 10,000 of those servers at the exact same time. That scalability, that is the heart and soul of DevOps.
So how do we start automating things like checking a server's health? Well, first you need to know how to check its vital signs manually. Think of it like a doctor. nproc tells you how many CPU cores it has. That's its brain power. Free-M shows you the available RAM, or its short-term memory, and df-h tells you how much disk space is left. Believe me, when an application starts running slow, these are the first 3 things an engineer is going to check.
Now, what if you need to see what's happening right now, live? For that, there's Top. Just think of it as the Linux version of the task manager. You run it, and you get this live, constantly updating dashboard of everything running on the server. How much CPU it's using, how much memory it's eating up. It's absolutely essential for troubleshooting, and I'll give you a hint. This is a very common question in DevOps interviews.
So when you take a bunch of these commands and you stick them in a file so you can run them all at once, that's a shell script. It's that simple. Just a few rules of thumb. The files usually end with .sh. And the very first line is absolutely critical. It has to be this thing called a shebang. That's the //bin/bash line. All that does is tell the system, hey, use the bash program to run the commands in this file. It's super important. And if you want your script to print something to the screen, you just use the echo command.
All right, we are in the home stretch now. But there's one last crucial piece of the puzzle. Imagine this. You've written your first awesome script. You're all excited, you go to run it, and denied. You get an error. What gives? Well, that brings us to the key that unlocks everything: permissions.
Get ready to see this message a lot when you're starting out. Permission denied. And yeah, it's going to be frustrating. But I really want you to change how you think about it. It is not an error message. It's a security feature. It's Linux stopping you and saying, well there, hold on. Who are you, and are you really sure you have the authority to do that? It's a learning moment.
So how do we give ourselves permission? We use a command called chmod, and it uses this really simple number system. Just remember this: read is 4, write is 2, and execute is 1. If you want to give a file full permissions, read, write, and execute, what do? You just add them up. 4 plus 2 plus 1 is 7. So when you see a command like chmod 777 on a script, it just means you're giving the user, the group, and everybody else full permission to do whatever they want with that file. The most important thing for us right now is that a script needs that execute permission before you can run it.
And that's it. That's the core of it all. Linux gives you that super stable, secure playground. The shell gives you the power to command it. You put them together, and you have the absolute, unbreakable foundation for your entire career in DevOps. The only thing left to do now is practice. Get on a terminal, use these commands, write a few tiny scripts, build that muscle memory. It's the most important thing you can do. So my question to you is, what are you going to automate first?